Hi, everybody. This is Stoichiometry Part 2. This is where we left off at the end yesterday. Remember that yesterday we were converting moles of one substance into moles of another substance using the coefficients from the balanced equation. This particular problem, remember, you start with the number that is given. I'm just giving you a quick review here. I am not going to erase that line. You know, that was just random. And we use the mole to mole ratio in this question. We're starting with water and we want to get rid of the moles of water, so we'll put that on the bottom. And we're trying to find the number of moles of aluminum hydroxide. So moles aluminum hydroxide goes on the top. And then where do we find the numbers to put in there? Remember, we go up here and we find the mole to mole ratio. For every 3 moles of water, we need 2 moles of aluminum hydroxide. And to get our answer to this, we would take this number, multiply by 2, divide by 3, and get 1.717 moles of aluminum hydroxide for our answer. So if you recall, that is where we had left off yesterday, and then you practiced it, hopefully with some success. This is the same decomposition reaction, and there are the coefficients to balance it. And this one, do you notice that in this problem, the part that looks a little bit different, if you notice it, is right here. That it is asking us to find the mass, not the moles, okay? Now, when it does that, okay, you have to start this problem just like you did yesterday with the mole to mole ratio. Like, we read this and we know this is our given number, 3.00 moles of aluminum hydroxide. So that's this one, because OH is hydroxide. Aluminum hydroxide. And then it says calculate the mass of water. First, you have to just do what we did yesterday and convert the moles of aluminum hydroxide into moles of water. Since we're eventually trying to find the mass of water, we first are going to try to just find the moles of water. And we look back here, just like yesterday, for every 2 moles of aluminum hydroxide, there's 3 moles of water. So 2 to 3. Now, do you remember earlier in the year when we first learned, to do these factor labels? If we were doing something that required more than one step, we didn't have to stop and get an answer and then do our next step. We could just string all of our steps together. Like if I said, my couch is 6 feet long, how many centimeters is that? I could do a step to go from feet to inches and another step to go from inches to centimeters. I didn't have to, if I said, okay, my couch is 6 feet, a foot is 12 inches. An inch is 2.54 centimeters. I didn't have to stop and get answers in between. I could just string these all together. 6 times 12 times 2.54, and I'd have my answer. Do you remember doing that earlier in the year? Where you can just string more than one step together. Well, that's how you do these problems where it asks for mass. You put more than one step together. And first, you do the same step that we already learned, this mole to mole ratio. And then you use a step from last unit. We know from the last unit that 1 mole of water weighs 18 grams. How do we know that? Because we look it up on the periodic table. There's 1 oxygen and it's 16. There's 2 hydrogens and they're each 1. That's a total of 18 grams. So we're going to convert from moles of water to grams of water using what is called, remember, let's see, get rid of that. Better get my Better get my OLAP back. We're going to, do you remember this? This is the molar mass of water. Do you recall that from the last unit? So we know that 18 grams is equal to 1 mole. Gosh darn it, I'm doing a lot now. I gotta improve that. So why do we put the mole of water on the bottom and the 18 grams on the top? We do that so that the mole of water will divide out. Should have gone back to my nice blue pen because then you can see how we're getting these labels to divide out. In every step, whatever the label is on the top, that's going to be the label on the next step on the bottom. In every step also, the top and the bottom are equal. Here we have the coefficients from the balanced equation. And here we have 1 mole is equal to the molar mass, which of course depends on the substance. Since it's water, we added up 1 oxygen and 2 hydrogens and got our molar mass of 18. But the top and the bottom of the factor have to be equal. And then once that is all accomplished, where we have the top and the bottom of the factor to be equal, and we've set up the units so that they all divide out, then we would take 3 times 3, divide by 2, times 18, divide by 1. You multiply by everything that's on the top. You divide by everything that's on the bottom. You don't hit equal until you're done with all of that. And I got 81. Now I'm going to do that again. 3 times 3 is 9, divided by 2 is 4.5, times 18, 81. And that is how many grams of water would be made in this reaction. So here's one to try. It is the same decomposition reaction. Now, while you're going through these videos, you can always, go back, okay, pause. So I want you to think about how you're going to do this. Remember, you start with the number that you're given. 2.015 moles of aluminum hydroxide. That's this one right here. This one's aluminum oxide. This one's hydroxide. So aluminum hydroxide. So then you got to ask yourself, well, what are we trying to find? Okay, we're trying to find aluminum oxide. So we're going to set up a problem to go from aluminum hydroxide, I missed my L, to aluminum oxide. And where do we get those numbers? Right here from the balanced equation. It's 2 aluminum hydroxide for every 1 mole of aluminum oxide. Now, I let that line there because it will eventually divide out, but the aluminum hydroxide divides out. We do still have a moles aluminum oxide label there. Our next step is going to be converting the moles into grams because it does ask us calculate the mass. So if we want to go from moles aluminum oxide to grams of aluminum oxide, we need to get the molar mass of aluminum oxide. We know that 1 mole aluminum oxide is equal to, add it up. You got to take 2 aluminums plus 3 oxygens. Look those up on the periodic table. Okay. If I take 2 aluminums, each aluminum is, you got to keep a periodic table handy, but each aluminum is 27. So times 2, that's 54 for the aluminum. And then oxygen is 16, but there's 3 of them, that's 48. And when you add that together, you get 102 grams. So there's 102 grams in every mole. So now the aluminum oxide moles will divide out, and you can see that my label is going to be grams aluminum oxide for the final answer. How do I arrive at the number? I am going to take the 2.015. I'm going to multiply by 1 and divide by 2. And then I'm going to multiply by 102 and divide by 1. So I take 2.015 times 1, divide by 2, times 102, divide by 1. And I got 102.765. I need 4 sig figs, so 102.8. Okay, so my answer is 102.8. Oops, I'm still on the highlighter. That's why it's writing fat. But feel free to, go through that again. Notice again, top and bottom of the factor equal. Those are the coefficients. Top and bottom of the factor are equal. That's the molar mass of aluminum oxide equal to 1 mole. Set it up so that my units divide out and I end up with the unit that they're asking for in the question. So try this one and then we'll go over it. Same, oh goodness gracious. Same balancing. Maybe pause it here and try and work this out on a piece of paper. And when you're done, restart it and check it against the answer that I'm about to work out for you. So start with the number you're given. So I'm trying to find aluminum hydroxide. So I'm going to go from water to aluminum hydroxide. And that's 3 and 2. 3 water for every 2 aluminum hydroxide. I want the mass, so I need another step, a mole of aluminum hydroxide. And I gotta figure out what that weighs. Let me see. Aluminum is 27. 3 oxygens, 3 times 16 is 48, and 3 hydrogens at 1 each. So 27 plus 48 plus 3, that is 78 grams in mole. To get my answer, 0.55 times 2 divided by 3 times 78. And I got 28.6. I got to round it to 2 sig figs. 28.6 rounds up to 29. I got 28.6, but then I'm just doing sig figs. So if I want 0.55 moles of water, I got to weigh out 29 grams of aluminum hydroxide and decompose it. That's how much is needed to make that many moles of water. Ooh, here's a new one to balance. This is a combustion reaction. This one's a little challenging to balance. So again, take a minute and try that. So this is one. It's a little tricky when you put a 2 here for the carbon and a 3 here to get 6 hydrogens. You get an odd number of oxygen. You get like 4 and 3, which is 7. You cannot put a number there and get 7 because times 2 is always going to give you an even number. So I don't know if you remember from balancing, but if you have odd on one side and even on another, it's good to double the existing coefficients. So instead of right there, the 1, 2, and the 3, I'm going to double that, and I'm going to make that 2, 4, 6. Okay, 2, 4, 6. And you can check this. There's now 4 carbon on both sides, and there's 12 hydrogens on both sides. So we kept the same ratio, so the carbons and hydrogens are still equal. But now we will have an even number of oxygen. We should have doubled it. Instead of 7, we should have 14. And we do, because we have 8 here and 6 here. And the last time I checked, 8 and 6 equal 14. So we've got 14 oxygens, so we can put a 7. So our coefficients, that's a little messy. I don't like that one. Our coefficients for this are 2 to 7 to 4 to 6. Okay, so now it is balanced. Now, if you look at this problem, it says how many grams of oxygen gas are required to react with 1.5 grams of ethane. Every once in a while, people look at problems and say, I don't know which one the ethane is. Well, like this is water, this is carbon dioxide, this is oxygen, so this one has to be the ethane. So kind of sometimes you have to, just do a little process of elimination. Also, it says the oxygen is reacting with the ethane, and if you look over here, that's what the oxygen is reacting with, the ethane. So do you notice that this is in grams? So if I go like this, and I have 1.5 grams of the ethane. Now, don't copy this down. I'm going to make a mistake, okay? But sometimes I will have people do something like this. Does anybody see something that is wrong with that? What's the problem? Do you see that these numbers are in moles and that unit doesn't match up because that's grams? Do you see that? If the number you start with is given in grams, the first thing you have to do is put it into moles so that you can do that mole to mole ratio that we learned yesterday. So C2H6, 2 carbons, 2 times 12 is 24, plus 6, 30 grams of C2H6 in a mole. Now, we're using the molar mass, and we put the step upside down compared to yesterday, because now we need to get rid of grams and get it into moles. No, I should not have said yesterday. I meant like on the last slide. Sometimes it all runs together. Sorry about that. So now we're ready to do the mole-to-mole ratio and switch substances from ethane to oxygen. It's a 2 to 7 ratio. I'm going to put the moles of ethane on the bottom, the moles of oxygen on the top. Why? So that my units divide out. Now, if this question said how many moles of oxygen, we're done, because our answer would be in moles of oxygen. But it says how many grams. We want the mass. So we have to add another step. Now, this is just like the last step over here. We're going to go from moles to grams. And the moles will be on the bottom. A mole of oxygen, we have to double the 16 because it's O2, is 32 grams. And our units, moles of oxygen, will divide out. Our unit that remains is grams of oxygen, which is exactly what we're supposed to find. How many grams of oxygen? And we take the 1.5 times 1, divide by 30, do not hit equals, times 7, divide by 2, times 32, and I got 5.60. I had to add that 0 to make it 3 sig figs, but I added that 0. So if I had 1.5 grams of ethane, this is how many grams of oxygen are going to react with it. Okay, try this one. It's the same balancing. Again, try it. Maybe pause. You try it on paper. And then I'm going to go over it in a minute. All right, see how I'm starting this way? Started with the given amount of ethane. My first job, since it's not in moles, convert it to moles. Now I will switch substances from ethane to carbon dioxide. 2 to 4. 2 moles of ethane produce 4 moles of carbon dioxide. Dang it. You see that so far my units divide out grams of C2H6, moles of C2H6. Top and bottom's equal. Here, it's 1 mole is equal to the molar mass. Here, it's the coefficients. If this question said how many moles of carbon dioxide, we're done. But it doesn't. It says how many grams. So I got to add another step. We know that a mole of CO2 weighs 44 grams. I add that up, 2 oxygens plus a carbon. Moles of CO2 divide out. To get my answer, I take 25. You can multiply by the 1 or, get the same thing. So I just go right to divide by 30 times 4, divide by 2. Sometimes people simplify those. That works too. Times 44. And I got, for my final answer, 73.3 grams. And then you can see that the unit is CO2. If I burned 25, because this is combustion, this is burning. If I burned 25 grams of ethane, I would get 73.3 grams of carbon dioxide. This is how, climate scientists sometimes figure out, hey, if we burn this many pounds or kilograms of fuel, how much carbon dioxide is it going to put into our atmosphere? They use known chemical reactions and stoichiometry to figure that out. Now, before you go and do your last worksheet, I want you to see there's 3 steps to the stoichiometry. Did you notice that this step 2, was in every single problem? If you look back to what we have done, and I just need a highlighter and I want to change its color a little bit. Make sure it shows up. Amount of red highlighter, that'll show up. If you look back, this step right here, the mole to mole ratio, was in every problem that we did yesterday in the first part of stoichiometry. And it's been in every single problem that we did today. Look, mole to mole ratio. Look, mole to mole ratio. Now the last step, this one, where you convert moles to grams, sometimes we have it, sometimes we don't. Okay? Here we have it because it says calculate the mass. But if this said calculate the moles, we wouldn't have that last step. We did problems like that where we found answers in moles and we didn't need this step. This is an optional step. This first step, where you go from grams to moles, this is optional. When do you need it? You only need it if your first number is in grams. If your starting number is in moles, like this one, we didn't need, there's no step 1 here. Do you see that? We went right to step 2, mole to mole ratio. So this, step 1, this is optional. You only need it when you start with a unit other than moles. Like if you start with grams, convert the number to moles using that 1 mole is the molar mass. You use the periodic table to find the molar mass. Okay. The second step, you always need it. It is in every problem. This is the very essence of what stoichiometry is. You're converting one substance to another using the mole to mole ratio in a balanced chemical reaction. And then notice step 3 is optional. When do you need it? Only when you have to put your answer in a unit other than moles. Like when it says find the mass, then you need that third step, like here, to convert the moles into grams. If this said how many moles of carbon dioxide, we wouldn't need it. But it said how many grams, so we needed it. But it's optional. You have to read the problem and see if it's needed. Now I'm going to erase all of this that's on here. In my opinion, this is a great one to like maybe screenshot or take a picture of, continue to refer back to. This is your summary. This is your guide for the steps of stoichiometry. The worksheet that you did yesterday, oops, I'm still on the eraser, only had these steps. Today, you might have step 1 and step 3, one or the other, or sometimes both. And what you have to decide is how many steps do I need? And remember, you always need step 2. You may or may not need step 1 and step 3. You have to read the problem and look at your units to decide that. But good luck. Hopefully you now can complete some calculations. Still on the eraser. Hopefully you can complete some calculations and put your answer in the right units with labels. Okay. Good luck with everything. There's a worksheet. Again, there's a discussion board for questions, and you know that your teachers will be monitoring discussion boards and answering questions for you as you're trying to learn these new types of problems. Good luck to you.